All right, here are our sum and difference identities for sine. Notice how sine is a lot more straightforward than cosine. If it's plus, it's plus. If it's minus, it's minus. Sine likes to share with cosine and not just put itself secluded away from cosine. It actually makes a sandwich, a protective sandwich around cosine, right? So sandwich, share, simple, whatever words will help you to remember these formulas would be amazing. So let's go ahead and look at this. Ooh, radians. This is more of a challenge to figure out angles we know that would make 19 pi 12. So let's do a little scratch work over here for a second. So I'm going to call it my scratch work, my thinking. We're looking for angles that add up to or subtract to 19 pi 12ths. So obviously we want to use angles that we already know the exact values of. So let's just kind of start at pi 6. What would be pi 6 if we changed it to pi 12ths? 2 pi 12ths, right? What if we took pi 4ths and changed that to pi 12ths? 3 pi 12ths. We are not anywhere near what we need to be. These two numbers only add up to 5, not to 19. I feel like we're going to have to get into some second quadrant angles. So what about pi thirds? That would be 4 pi 12ths, right? Just keep going. So pi halves would be 6 pi 12ths. Let's go to maybe some second quadrant angles. So what about 5 pi 6? I guess I'm going to start with the big ones this time because I just wanted to kind of correspond them. So pi 6, 5 pi 6, that would be 10 pi 12ths. What about 3 pi 4ths? Oh, come on. 3 pi 4ths would be what, 9 pi 12ths? Oh, what do you notice? I think we got something. 2 pi thirds, just in case you need to keep going, but you shouldn't have to. 2 pi thirds would be 8 pi 12ths. Do we have anything that's going to add up to 19? Yeah, should we stop since we found some? Okay, so right here, these two will add up to 19 pi 12ths, correct? All right, here we go. So we're going to take our sine of 19 pi 12ths and rewrite that as sine of 5 pi 6 plus 3 pi 4ths. And that's because equivalent values of those fractions are 10 pi 12ths and 9 pi 12ths, which adds up to 19 pi 12ths. So we just kind of did our little scratch work over there to figure that out. Okay, so now we're going to use our identity. So it's going to have the same sign, right? It's plus here and it's plus there. So sine of 5 pi 6, we're going to share with cosine. So cosine of 3 pi 4ths. And keep the sign the same, so plus cosine, we're making a sandwich, so cosine's going like in the middle. 5 pi 6 sine of 3 pi 4ths. All right, now we got to remember what these angle values are. So we have 5 pi 6 here. Remember, all students take calculus, so our sines are going to be positive and our cosines are going to be negative. So 5 pi 6 has the same as pi 6, which is 1/2, isn't it? Do you remember me saying you want to have this chart memorized? Yeah. Memorizing your chart is going to keep helping you all year with things when we plug in different things. We just need to know what those numbers are. Now notice how after I find the sine of pi 5 6, I've written down the answer 1/2. I don't keep the sign anymore. It's literally the sine of 5 pi 6 is 1/2. So the 1/2 is replacing the sine 5 pi 6. What's the cosine of 3 pi 4ths? What is our pi fourths reference angle from our little chart? Perfect. However, it's quadrant 2. What does that tell us? Yep. So the cosine of 3 pi fourths is negative square root of 2 over 2. And then the cosine of 5 pi 6 is the same as the cosine of pi 6, except it's going to be negative. So what's that value? Negative square root of 3 over 2, yes? And then the sine is 3 pi fourths, in quadrant 2, sine is positive, so that's just going to be a positive square root of 2 over 2. So this part of the problem just comes from the stuff we learned in chapter 1 with assigning, finding the ratios of those special angles all the way around our circle and knowing whether they're positive or negative and etc. Okay, so now we multiply this stuff together. We get negative square root of 2 over 4 plus negative square root of 6 over, yes, that looks like a 6, over 4. So we get negative square root of 2 minus square root of 6 over 4. We just get the opposite of the answer that we got for the cosine of 15 degrees, right? So it must be like the sine of 75 degrees, but in a quadrant that makes it negative. Let's think about 19 pi 12ths. That would either be quadrant 3 or 4. I think it's quadrant 4. And so that would be a negative answer, which it is. And it's also somehow related to the cosine of 15 degrees, just negative. All right, let's look at